In this word problem, we're going to see how to apply a directly proportional type word problem. Let's go ahead and read just the first sentence. The distance d required for a car to stop after the brakes have been applied is directly proportional to the square of the car's speed x. So the word I got out of the first sentence that was most important here is the word directly proportional. When I see that word, or varies inversely, or varies directly, I know it's my special formulas. So let's write those down. So we saw from the last video, if y varies directly as x, we use y equals kx, where k is a constant. If y varies inversely as x, we use y equals k over x, also k is a constant. We also saw that another word for varies directly for just the directly one is directly proportional, which is what we have here. But there is a little difference in this formula. We have here that the distance required for a car to stop after the brakes have been applied is directly proportional to the square of the car's speed. So let's highlight that. The square of the car's speed. So we don't just have y varying directly as x, now we have y varies directly as x squared. It's the square of the speed car. So we would have a squared here and a squared here. If it was y varies inversely as x squared, or the square of x, we put a square there as well. By the way, if it was a cubed, we put a 3. Y varies directly as the cube of x, and so forth. So this one we're going to use the x squared. So I'm going to go ahead and write down that formula. Y is equal to kx squared. Now what is y? We have two variables, y and x. Well, y is usually the variable that is before the words varies directly or directly proportional. And if you see here, the variable before is the distance d. The distance d required for a car to stop is directly proportional. So y is the distance. And we have that x, we already talked about that, that's in blue, the square of the car's speed. So x is the car's speed. Oh, and that is x. There's no other variable there, so it's the car's speed. So if I'm going to use my variables that they give me, this would be a d equals kx squared. That's the actual formula. So now let's go on and read the second sentence. If a car is traveling at 66 miles per hour, so we know that, and we have x and d here, or I should say d and x. D, if you remember, is distance, and x is speed. So miles per hour, that represents a speed to me. So that's 66. And that tells me that the speed up here is going to always be in miles per hour through the whole problem. And the distance they give me is 396. So we know that that is 396. And that is in feet, not even in miles. That's kind of weird. But that is the proportion. Okay, so now using that we can find the k. So I can plug in 396 for d. We do not know what k is. Plugging these values into here, we get 66 squared. So if you take 36 squared, if you use your calculator, that is 4356. If you want to see it by hand, I can do it over here in Scratch. 60, we'll just do it over here, 66 times 66, yes, I know that's ugly, is 636. That would be 36 plus 3 is 39, and we would get it again, and you can see that that is 13. I did do it right. Okay. Now dividing both sides by 4356. 4356, we would get, what would we get? Well, I again, using your calculator, I think it's 1/11th. If you want to see that work over here, I can see these numbers in here, so I think that they both divide by 66. We just found this one is 66. So if I take 66 into 396, what do I get? You do get 6. Let's see, times 6. Yep, you can see it over there. It's actually right here. So that would be a 6. And now you could divide 6 into each, and you can see that it's 1/11th. What I probably would have done is just use my calculator, seeing if 396 goes into the wrong way, 4356, and that would have been 11 times, but the numerator is smaller, so that would be 1/11th. So let me erase my scratch. So this gives us now a new formula. We have d is equal to 1/11 x squared. That is the formula. Now I can use k as a constant, and O is going to remain no matter what values I plug in, and we can now use this formula to answer any question they give us. So let's go ahead and do that by looking at the second part of that second sentence. It asks for how many feet required to stop the car at 33 miles per hour. Okay, so again we got d and x. How many feet? If you notice up here, that is our d. That's what we're looking for. How many feet? 33 miles per hour is a speed, and that's, the units are in miles per hour, so that's good. So if I just plug in, using this formula, 33 for x, I will get my answer. So again, doing it again, 33 squared, just use your calculator. You could simplify this kind of nicely, because this is 1/11th times 33 times 33. If you didn't want to use your calculator, and that is a 3 there. So you can see the answer would be 99. Or you can do it like I did over here, multiply the 33 out and divide by 11. Whatever you do, we know the answer is 99 feet. That is our answer.